Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, today we've got a pair of odd TRS-80 Model 100s. Now, this one in the back here with the blonde keyboard, this one's odd. That's not the normal keyboard for one of these machines. So, has it been swapped in from another machine? If so, what machine? Let's find out. This one down here with the regular old black keyboard, you notice it doesn't have a badge to the right of the screen. That's because it is actually a prototype unit from one of the Tandy engineers by way of a friend of mine. This one is absolutely unique. There's not another one like it in the world. So we're going to have a look inside these things to see what makes them different and to see what it'll make to make them tick again. Let's get started. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. Let's start with this Model 100, which has a blonde keyboard. Now, it is quite a difference from the original black, and you can see that, well, these are the same, except this says insert delete, this says delete backspace. Other than that, they're exactly the same. This says tab, this has arrows, that type of thing. Pretty much the same. So where did this keyboard come from? Well, this is actually from a Kyocera KC85. Kyocera is the company that originally developed this line of computers, and they customized design for Radio Shack, for Olivetti, etc. And this is the type of keyboard that would have gone into the Kyocera KC85 rather than the Model 100. So did it get swapped in here at some point as a replacement for a bad keyboard? We'll find out. Before popping the case open, let's have a look at the back. Okay, if we look here on the back, we have our normal model number label and FCC ID label, except they've had a second label stuck over them. This says catalog number 263802. And if we look at another Model 100, we'll see it says catalog number 263801, and it has a regular FCC ID label. So what's the difference? Well, the 3802 came out in the same year, 1984, as the 3801. This came with 24K installed, and the 3801 came with 8K installed. Because the machine was equipped differently from sale, it had to have separate certification for the FCC ID to make sure it still met those requirements. And a lot of times if you had a product UL listed, it had to go through UL again too, even if you change one part. So these stickers aren't a big deal. I think this one just got worn off. So probably what happened, I'm guessing, is Radio Shack had a bazillion of these stickers printed, then decided to offer the 24K version up front, and had these stickers printed real quick so they could get on with production. Of course, I already popped this thing apart to make it easier, and if we notice, it looks like a regular keyboard, regular LCD. If we look really close at the paint locks here, it's over here on this screw, but here on the bracket, same thing here. This one's off, and this one's a little off. These two in the corners are off. So I would say for some reason this KC85 keyboard was swapped into this unit. It was not original. And even though this should have been a 24K from the factory unit, it only has one RAM chip soldered in, and it has the other three are a third party RAM chip, not the originals. So was this thing pieced together from lots of different parts? Maybe this was a 8K board that was swapped into this case with a KC85 keyboard. Other than that, it looks bog standard. I give a quick look around all the caps, and surprisingly, there looks to be no or almost no leakage. But given the history of these guys, I will go ahead and change the caps on this. I've done a lot of videos on that, so I won't show it. But I think before doing that, we'll go ahead and plug this in to see if it does happen to work once we give the memory battery a little while to charge up. Here is our prototype unit. You notice from the outside it looks to be in good shape, but not any different save missing this badge. It looks like a bog standard Model 100. This actually came from longtime Tandy engineer Frank Druda's estate through a friend of mine who was nice enough to pass it on to me. At some point, I'm trying to find something worthwhile to trade back to him that he's interested in. If we look at the back of this guy, the trap door here looks a little different. I think this was an option when you got the DVI. This part was cut out. This looks like it was done by hand, but it's not textured, and it's a little slick, so it may have been a prototype. We can see evidence of a bodge right there. I just pushed it back in, that yellow wire. This has the 263801 regular model number sticker. There's no FCC ID. This is a prototype, but it's never gone through that. We're missing a couple of feet, but no big deal. Go ahead and pop the case open on this one. Okay. Already took the screws out to save us time. And keyboard side, other than the different Alp sticker, which is all in Japanese, it looks pretty much the same. LCD looks the same. The only thing I notice on here is that there is no paint lock on the screws. This is not a production unit. Now on the motherboard, just from a cursory glance, we see there's a lot of different stuff here. This was an 8K unit to start with, so it's had 3 8K modules added for a total of 32K. This is a standard ROM. There's nothing different about it. The DC jack here is not the original, or it was changed at some point. It does not have the protection diodes and resistor in there. If we compare this to a standard board, what's the best way to do this? Maybe like this. You can see on a standard board, this big capacitor here is bent over. The leads are on this end, whereas this one, the leads are here. There's not even holes here. The battery contact thing is longer here. And it looks like the board shape is the same up in this area where the contrast pot is. This is different. Some of the resistors are moved. You notice on this production board, we have these 2 leads twisted over, running from the reset circuitry up here over to the CPU. That is a delay line. And here we have something like that added. We've got a wire jumpered to, what is that, pins 8 and 9 on M27. Pin 10 is running over to the CPU, which is coupled to a capacitor here. There's a couple resistors here. If we zoom in here on the board, you can see we've got some resistors kind of standing up and soldered together. On the production board, these are 1% units, and it looks like here they're experimenting with the correct values, so they put 2 resistors in series to get the exact value for that. We see that in 4 different locations. There's some resistors that are standing off of the board. I'm guessing that means they were changing those values too. Here's some other resistors that were done that way. This is a resistor in series with the diode. Some capacitors doubled up here. This capacitor right here was bodged in, and we can see on the final production revision that it was actually added in here. That's C103. This had the 5.6K resistors in the output like the early production units of the Model 100 had, whereas they eventually switched to the 330 ohms. All the chips on this board are in the same area, it looks like. There are a few miscellaneous components shifted to different positions. Like I said, some things tacked in. But everything looks good. Again, on this board, I'm not seeing any evidence of capacitor leakage. I'm not sure if these values are exactly the same as the production units. So I'm going to have to pull these capacitors one at a time and double check the values and replace them one at a time, which will take longer, but that's the only way to be safe in doing so. Because of the propensity of the capacitors from this age on this model leaking, even though this is a pre-production unit that has some different brands of capacitors, I am going to go ahead and change them, and I'm going to try to leave everything else exactly as it is so we can keep this as a prototype. Now, when I got this, it had some nickel metal hydride batteries in it. These are 1.2 volts. So my suspicion is here in the low battery detect circuitry, it was probably modified to work with the 1.2 volt cells. You'd want the low voltage detect to kick in at a later time than on the standard 100. So we'll try to find those resistors that are in here and compare it to a standard production model. Okay, so I think what I'm going to do is plug these guys in to let the memory batteries charge, and then we'll try them out, see if they work. We'll measure the voltages to see what's going on, and that way we can kind of make a game plan to know how we're going to attack them and get these fixed up. I charged both units for a number of hours to see how that memory backup battery was doing. Both accepted a bit of a charge, but they're running down pretty quickly, so they're definitely both shot. Here we've got the one with the blonde keyboard, and it booted right up, no problem. Beeper works. Pop it open here, which is suddenly easier said than done. There we go. Yep. Pressing the return key. There we go. Again, this is sort of a Frankenstein unit. The serial number on the case indicates that it should have came with 24K, so these three should have been soldered in. This would have had the socket for an optional plug-in. This has only one soldered in, so this would have been originally an 8K unit. It has the KC85 keyboard. Other than that, it's bone stock. And we can check out the voltages here, and it always works better if you can prop your voltmeter up on whatever system you're measuring. Actually, that's not true, but in this case it worked better for the camera. And of course we've got marks right here on the board. So we've got VEE minus 5 volts, VDD plus 5 volts, and VB, which is the battery charging voltage. So it is charging the battery, it's just not retaining a charge very well. This is a stock unit. Even though the capacitors don't look like they're leaking now, they are starting to leak, I guarantee it. So this is going to get recapped, and I think what I'll do actually is put one of my spare Model 100 keyboards on this and take this KC85 keyboard and put on my KC85, which has a partially broken keyboard. Then I'll have a good Model 100, it's in good physical condition. It's loaded up with RAM, etc. And I'll have a KC85 that looks better. And sometime I'll do a video on refurbishing that KC85. One thing I want to point out before we look at the prototype unit is this extra wire right here. This is the speaker wire. It runs to here on the LCD. This wire on the LCD runs to the speaker, which is mounted right under there. That's the two screws we can see sticking up where the label should be. On the prototype unit, this is not there, but it still beeps. So I didn't realize that yesterday when we were looking at these. So this one's bog standard, built from parts, keyboard from a sister model. All right, here is our lovely prototype unit. Again, I kept this plugged in for several hours. The memory backup battery takes a charge, but it bleeds off really fast. It's shot after 40 years. It does power up. The LCD looks great. Beeper works, even though, get this rotated around here, we don't have this extra wire running from here up to the beeper. It's just in the ribbon cable. It's got the same number of slots here on the ribbon cable, but it's got to be using one of these wires to control the beeper. And you see we've got the wire running from here down to the actual beeper. So this is different than the production units. And I think I already pointed out this 5-volt wire that was shorting out under the board. But if we measure all of the voltages here, minus 5 volts. Oops, you guys can't see the meter. Silly me. Okay, here we go. Remember to put your meter on the piece of equipment that you are measuring. Works much better that way. No, it doesn't. Don't pay any attention to me. Minus 5 volts is minus 5 volts. Plus 5 volts is 5 volts. And, oh, that was VB. It's 5 volts. 5 volts for plus 5 volts. So all the voltages on here are okay. These are not the exact caps that are in the production unit. And since this is a prototype, I'm going to be a little more conservative in what I replace because I would like to keep it as original as possible. The battery really needs to go though. That looks like the stock Yaesu battery. So one other thing I wanted to show you, if I can sneak my probes under here. Let's see. Maybe I could go like this. Create a little more room. All right. I pointed out before that the external power connector was wired differently. Yeah, there we go. Okay. One other slight issue with this machine, which I'll get to in a minute, is this connector. This connector is wired a bit differently. The switch is bypassed. So it does put the applied voltage directly onto the batteries. So charging 4.8 volts of 9 CADs, which came into it at 6 volts, is probably about as much as you'd want to do. This is a switching power supply right here, so we could put in a lower voltage to safely charge the batteries, but you would not want to put dry cells in here, your regular batteries, and plug an external charger in here because it's going to try to charge them, and there does not appear to be any other circuitry in here to control charging. So anyhow, just an FYI, this where the power connects right here is wired differently as well. So you know, I'll pull these caps out, the sizes that leak most often, and spot check them. And I won't replace them unless they need to be. I will replace the battery. And this socket is corroded inside. This is a common problem with these things, so I'll show you how to clean that. One other thing I noticed is that this prototype unit does not have the RF shield down here. So we've got slightly different layout. External power input is wired differently. We've got a different LCD cable with the buzzer signals built into it, so that means this LCD is different. And we've got bodge wires all over the place. In the description, you'll find a couple high-res pictures of the front and back of this board, so you can try to spot other changes I might have missed. To clean the external power connector, I'm going to take some deoxit and squirt just a tiny bit in there like that. Then I'm going to take a flat blade screwdriver and very carefully scrape this flat contact right here. All I'm trying to do is get any crusty stuff off of there. Like that. Then I've got a brass brush. I've got you can extend the bristles out a little bit. Got those extended out. And I'm going to work that in there. Just not always easy. Like that. Just work that around, rotate it, run it in and out. Just polish that up real good. I haven't found anything else that works better inside that socket than the brass brush. So I'll work on that for several minutes. I'll let that deoxit stay in there for, a couple hours. Let it keep doing its magic. And in my experience, that'll fix up one of these connectors pretty good. So I pulled out these 4 10 microfarad caps, which are normally the worst. And I'll pop some photos up here. You can see that they were just starting to leak. The corrosion had made its way through the hot air solder layer, and just a little bit of the solder mask peeled up and cleaning. I'm probably not going to go ahead and add some more sealant on that. I might. I'm not made up my mind yet. Usually the worst caps on these boards are those 10 microfarads. These two guys, these two, and that one, all the smaller ones. Usually the larger ones are not a problem at all. They can be, anything can happen, but I just got to wondering today if the problem with the smaller caps was maybe mechanical. They didn't get the crimping right to start with because they were so small when they were crimping the end on, and it wasn't making a good seal, or maybe the seals they were using weren't good. Anyhow, they figured it out within a few years. So I'm going to go ahead and go through the rest of these small caps, replace the ones I pulled out, and replace the battery on this board, and then do a complete test with the test harness. And then I think we will call this good. I want to do just as little work as I have to this prototype and leave it in as close to the original condition as I can while maintaining it functionally and making sure that the caps aren't going to eat the board away. Okay, I replaced these 4 capacitors, the 10 microfarad, these 3, these 2, and this guy. This one and these 2 really weren't bad, but I'd already pulled them out. And I found that C85 and 86, which are this one, that's C86, and where is C85? C85 is this one. They were different values than what the production units were, but they're in the power supply section, which I'll show right here. So I'm guessing that they found having a little bigger capacitors in there helped in some usage cases, so they switched to that. I hooked the test harness up. Everything works. I'm getting ready to run the second pass. I just need to turn it off, turn it back on. My LCD loopback dongle here is a little flaky. When it gets tweaked, sometimes it doesn't loop back properly. So one of those tests may fail, but that's just in this guy. We know the LCD works. See if I can get you zoomed in here on the LCD readout of the test harness. I thought that was pretty cool that, yeah, see, part of the address lines on this dongle fail, which is perfectly fine. The other ones pass. It may be one of these chips needs to be resoldered. I just haven't bothered looking that far at it yet. So all the bodges done to this seem to have really brought it up to pretty much the same as the production level, because all these automated tests are passing, all the memory's testing good. There's some differences. I noticed that the pot knob over here for the contrast, that's right there, is a little different. It doesn't have the shroud. I'll pop a picture of that up here. Pin 30 on the LCD connector is not used on the production models. On this one, it runs to the beeper instead of having the separate connector. Don't know why they did the separate connector. And look at this picture here. I managed to take the eyelet that I ripped off when I removed the original battery, which is up there, and push it back down through the hole. And since the actual traces on the bottom, it didn't make any difference if the eyelet's broken. But looking at it now, it doesn't look damaged, so only you and I are going to know. Don't tell anybody I screwed that up. Oh, we got a parallel port right fail, probably because I propped this thing up. It passed before. Yep, so I'll run this through a couple more times, set it back down so it's not in filming posture, and make sure it does pass one more time, and then we'll clean the case up and put it all back together. Well, we've got our two unusual Model 100s back together, and they're both working. On the Frankenstein unit that originally had the blonde keyboard, it's gone back to its natural brunette color, and I recapped it. It leaked in some different spots than the prototype did. I'll pop a couple pictures up here. Had a new memory battery installed, that type of thing. I cleaned the DC power jack like I did on this one. So this one's in good shape, and I'm going to take this to Tandy Assembly and add it to the auction that raises money for the event. I will also take our prototype Model 100 here for display only. It's not being sold. It's not mine to sell. I just agreed to take care of it until such time I'm no longer around. And so on this one, I went through and replaced all the caps. This one, I only did the caps that I had to do to keep it as original as possible. You may have noticed that on the prototype, the spring contacts looked a little wonky. I think the reason was that Mr. Druda must have bent those out to make contact with the nickel metal hydride batteries, which are flat tops. I didn't have the little protrusion on the positive end of the battery. I had problems with them in my nickel metal hydride battery charger making contact, so I had to like bend some 22 gauge wire shims to slide in there on the positive side so it would make contact, and I'm trying to rejuvenate those now. I don't know if they're still good though. So at any rate, the way the DC jack on this one's wired, we can't use regular dry cell battery, alkaline batteries in here. Use only the rechargeable batteries, or just leave the batteries out and use the external power jack. But we got both units going. They were both interesting. I've got a spare KC85 keyboard for my KC85 that has a partially broken keyboard. So all in all, I think we did good. Questions or comments, leave them down below. I'd love to hear from you. Again, I took some high resolution photos of the prototype board, so you can compare it to your Model 100 if you want to. There'll be a link to that in the description. And until next time, bye. Let's start over.